The answers as best I know them to pretest 11A. Chase, are you ready?
Yes.
Number 1 should be $30. Cass, you don't have a test? You don't have anything?
What?
Oh, that was because you're not in Algebra 1. Nobody has? Who took Cassie's pretest? I know I gave stuff out. Somebody? Oh, what happened?
Big whoop in the chat.
How about this? Hold on a second. 11A. But you could borrow late for right now until I can come up. Sorry, it's not. He doesn't need it, correct? I know I had it. All right, so how about this one? 11A, 1,600 feet cubed. 1,600. Number 2 is 40. 2 is 40. 3 is 900. 900. 4 ends up being 41. 41 yards. 5, the coordinates are, in parentheses, all of these, 6, 6, negative 3, 6, negative 3, negative 3, and 6, negative 3. Number 6 is 40 degrees. 7 is $70,000. $70,000. Number 8 is 0.408. 0.00008 meters. Oh boy. Number 9. Number 9 looks a bit like this. Yes? I will look again to make sure I have that wrong. Try this. Let's, can I erase the batch for that? I did not write any of that up there, just so you know. How about this? Number 10 should be 5'6". 10 is 5'6". 11 is 21. 21. 12 is 1.4. 1.4. 13 is 1.6 times 10 to the third. 1.6 times 10 to the third. 14 is 1.2 times 10 to the 8th. 1.2 times 10 to the 8th. 15 is 8x squared. 8x squared. 16 is 4.5. 4.5. 17 is 6x squared minus 4x. 6x squared minus 4x. 18, 5x minus 2y. 5x minus 2y. 19 is the letter C, as in California. And number 20, 314 inches squared. 314 inches squared. These would be the times that you could ask a question or two. I suspect there will be a question. Let's just take a random poll. Who missed 0?
Hey.
Nice.
Wait,
Who missed 1, 2, 3, 4, 5. 5. There's our starting point. I love it. You just need to look at this as not missing 5, but figuring out 5 problems. Look how much smarter you'll be. Remember that one test where everybody got like C?
Oh, yes.
I have to ask you again. Did you always use it or what?
No.
How can you go from babies to this?
Paper, sorry. I know.
Alright, here we go. Autumn console. Number 20. And again, remember my things to do, you know, when you're allowed to use notes, I don't know why you would not want to use notes. I can let you give yourself, can't use the pretest or its answer, but you certainly can say, hey, make sure you multiply on this one or divide on this one. The diameter of a cylinder barrel was 20 inches. When the barrel was lifted away, it left an imprint of a circle on the ground. What is the area of the circle? Key words there probably are, so you know you have a circle. Do you know the dimensions of that circle? Diameter was 20 inches. I think they give you everything you need to know. And obviously in your notes you'd write down the formula of Madison Sittler for the area of a circle, which is
Pi times radius times radius.
area equals pi times radius times radius. And apparently, they didn't say to use 3.14 for pi, but apparently you do. I guess if you put 100 pi, that would be acceptable, because they didn't tell you. But and then in my notes, the note itself is, what I was given here was not the radius, but the diameter. Autumn, what is the radius of this circle? 10. So it's just a matter of filling in the blanks here. Area equals 3.14, because that's what we use for pi, times 10 times 10. At this point, ladies and gentlemen, it becomes mental math, does it not, Chase? Why is it mental math, Chase? Because 10 times 10 is 100. And anytime you multiply a decimal number by 1 with zeros, you just move the decimal however many zeros it is over. I'm going to move the decimal 2 places. My answer is 314. Whatever that is. Inches? Inches. Squared, because it's area. If you don't know the mental thing, I guess you can always do it like we do normal. Multiply by 100, hang out the zeros. 0, 0, 4, 1, 3. Move the decimal back 2 places. You get 314. That's not so bad. Like Rocky said to, who did he say that to? You're not so bad, you're not so bad. My mother hits harder than that. I think it was Apollo. Apollo Creed? No, it was probably Mr. T. Nobody watches Rocky. So,
How would I do number 18?
number 18, let's see where we're at. Number 18. Hopefully at some point in your lives, dear children, when you start seeing parentheses, automatically the first thing you should think about is it's probably what? Somebody? And it's probably, Joseph, probably the distributive property. Is that what you're going to say, Joseph? So I can cut you off there. So in order, and you can't, by the way, the next thing you look at this and you see, are there equal signs up there?
No.
There are not. So you can't get an answer. You're not going to get x equals something. The only thing you can do is what we call simplify it, which means combine like terms. But before you do that, you have to do the distributive property. What is 2 times x? 2x. What is 2 times a minus y? Minus 2y. What do you still have over here? A 3x. Again, no equal signs. I can't see what x equals, but I can put some terms together. And here's where you just need to think about that. This is not multiplication, this is addition. You have 3 x's, x plus x plus x. And I'm adding 2 more x's. And that gives me 5 x's. And this one doesn't have any other terms like it, so it ends up minus 2y. Surging forward at breakneck speed, Emma Miller.
How do you do number 7?
Number 7. Look at that. Talk about that for being right on the money. Number 7, notes to self. The question asks you this. The house with the highest selling price, which is pretty easy. If I look at that, I can tell the highest selling price, that's this one, right? Is how much more than, now one would think they'd say the least, the smallest one, but it doesn't. It asks you for the median. And in order to find the median, which means middle, what do you have to do? Step number one, you have to arrange them from least to greatest. How many people did not arrange from least to greatest? You're going to want to do it. Now, something that might speed up the process, since they all end with 3 zeros, you really don't have to worry about the zeros. Just know that it's in thousands. The smallest one you have is this. Oh, I guess it doesn't. It does have. I guess we do need, there's that 5 there. 297, 500. Oops, I don't want to put a count. That's the smallest, and then from there we go to 328,000. And then from there we go to 345,000. And then we go to 389,000. And finally we wrap things up with the biggest one, which is 415,000. Did I get something wrong? And fortunately for you, there is a middle number. If you have 5 numbers, the middle number is going to be, Emma?
345,000.
Right, 345,000. Now that is the number you have to find. You want to see how much more it is, so you're looking for the difference. So it's a subtraction problem now. The highest one was 415,000. The median is 345,000. With a little bit of work here, you end up, I believe, with 70 grand. Did you get that right? 2 for 2, 3 for 3. How many people got that wrong? How many people won't get it wrong tomorrow? It's really, I mean, it's not complicated. It's maybe kind of confusing, but not very difficult. More, Autumn Consul.
I need number 16.
Number 16, children. One of my favorite problems in the history of math. Autumn, what do you think you should do?
Subtract the 2 top numbers.
Very good. Absolutely. You have to do this, and then your last thing you're going to do is divide those out. Why do we do that? Because a fraction line is a grouping symbol. It separates this into one part. It separates this into one part. You need to simplify them, get them down to one number, and then you do that division part. What is 1.2 minus 0.12? Remember with decimals, you line them up when you add and subtract them. So it looks like I get 1.08. Am I right? Am I right or am I right?
Right.
On the bottom, it's multiplication. You don't line up decimals for multiplication. You just multiply it out. 0.12 times 2 is 24, but I count decimal places. There's only 2 in that top, so it's 0.24 on the bottom. And then note to self, because decimals get kind of confusing as to which one goes on the bottom. You are dividing 1.08 is getting divided by 0.24. Why do you think the book puts this problem on a test? Because it deals with 3 out of the 4 things you can do with decimals. And you do different things every time. It gives you subtracting decimals, it gives you multiplying decimals, and it gives you dividing decimals. And it's making you a better person, believe it or not. So, what do I do here? Review again. You move the decimal out so it becomes 24, but however many places you move there, you have to move here. Decimal goes here in my answer. 24 doesn't go into 1, doesn't go into 10, but it does go into 108. John, how many times? 4 maybe? 4 times 24 is 96. Subtract, I get 2. 10, 9, 1. Yeah, decimals you have to keep going until they work out. 4 goes into 100, or 24 goes into 120. Zachary. 24 times 5 is 120. Oh, look at that. What a great way to end the problem. 4.5. How many people got that one wrong? Again, the problem is not getting it wrong today, because it don't really matter today. Tomorrow, on the other hand, painful. Caleb Fisher.
What did you do wrong too?
How would I do it?
Yeah.
I don't know. Probably the way the book says. 2. Oh, gee whiz. What did you try, Caleb Fisher? Did you draw me a percent box?
Yeah.
So this is the way it would look, children. Again, you can do this your way. If you understand it a different way, that is fine. Percents are ratios. I put my percents here. I put my actual numbers here. And it doesn't matter, you can put percents over there, but I really like to keep them in that left-hand column. And what are we comparing? We are comparing the correct to the incorrect to the total. We should be able to fill in at least 3 or 4 of those boxes. Well, the first thing I see is the word 6. 6 of Simon's answers were what? Is that a percent or is that the actual product? It is the actual. And then it says 85% of his answers were correct. Is that actual or is that a percent? I wonder. And they were the ones that were correct. Here's where a little common sense has to come into play. We pretty much always know that total is 100%. If 85% were correct, what percent were incorrect? 15. You do the subtracting there. And then you need to figure out, do they want how many correct problems you did or how many total problems were on the test? It says how many questions were in all. This is the one you're looking for. So here is, I'll write out the fractions that are equal. This 15 over 100 equals this 6 over what number? Once you get to that point, it's kind of your choice how you want to solve it. You can jump right into cross products right away and do this. 15 times n equals 6 times 100, which is 15n equals 600. And how do I solve that? Divide by 15. I won't bore you with the gory details of what that is, but it goes in there 40 times. Or you may be able to make your life easier by doing what before you did all that you could have. Anybody? Zachary? I could have reduced 15 over 100. Now remember, you can't do 100 with 6. That's only when you multiply fractions. When they're equal fractions, you can't do that. But you can reduce a single fraction, divide them both by 5. I get 3 on this side and 20 on this side. And then it's pretty easy because 3 to go to 6, you multiply by 2, and 20 times 2 is 40, which is what this thing is here. If that didn't make sense to you, certainly go right to there. Who's excited about this stuff? I am personally excited about it. So I'll be here. Much more exciting than I'm not here. Madison Sittler.
How would you do number 9?
El numero nino. For the function x, y equals x minus 2, make a table and graph. Huh. So you have this equation. Are you struggling with how to make a table?
I made a table.
Because your dad can build stuff, right? He probably knows how to make
I'm just
tables.
confused on how my line goes like this. And
Oh, well, that's a good thing. How about this, Madison Sittler? What numbers did you pick for x?
2, 4,
2,
6.
4, and 6. So when you took 2 and subtracted 2, you got?
0.
When you took 4 and subtracted 2, you got?
2.
And when you took 6 and subtracted 2, you got?
4.
Now, here is where Madison says everything fell apart. My guess is you flipped around your coordinate system. This is the ordered pair 2, comma 0. This is the ordered pair 4, comma 2. This is the ordered pair 6, comma 4. So when you graph it, over 2, up 0. Over 2, up nowhere. Over 4, up 2. Over 6, up 4. And you end up with that same line that I think we drew.
Okay.
Was that it?
Yeah.
It's always the x. It's always the over number first, and then the up and down number second. 4, 2. Autumn.
What do you do number 13?
Number 13. Well, if I go back to my notes about dividing with this, with what is that called? Scientific notation. Rule number 1, Bri, is to do what? Wow. Rule number 1, Emma Miller, is to?
Divide 3 and 4.
Yeah. Take the numbers that are on the left and divide it out. And if I divide 4.8 by 3, I'm not going to, well, I'll do the math. Sure, why not? 4.8 divided by 3, move the decimal straight up, is 1.6. Which should make you smile. Does anybody know why that should make you smile? John, why does that make you smile?
It's already between 1 and 2.
Yeah, you're not going to have to move the decimal in the end to make it between 1 and 10. Step number 2 is probably the hardest step of all. Emmy, what is step number 2? Right, you write down times 10. And then my personal favorite of all is step number 3, which would be what, Joseph?
Subtract the exponents.
Yeah, and make sure you subtract the bottom from the top. This one gets subtracted from that one, so it is 8 minus 5. And 8 minus 5 is 3. Now that's not to say that tomorrow you're not going to have to move stuff to make it in scientific notation. So step 4 is you need to make sure it's in scientific notation. Maybe that's why we should do the next one. There's your answer. As long as this number is between 1 and 10, we're all good. Let's do 14 just because everybody's dying for that one to be done. And we'll switch to a beautiful color of, I hate green, but I'll use it because it is. What's different about multiplication, Grace? The only thing different is, well, there's 2 things different. Well, no, there isn't. One thing different.
Add exponents.
Yeah, you add exponents. You still multiply the numbers. This time it's multiplying, so that becomes a 12. John, why does this make you frown?
Because it's not the same number.
Yeah, because you're going to have to move the decimal in the end. You still write down times 10. And like Ray said, now you add exponents. 4 plus 3 is 7. But that would be the wrong answer because... So what do I have to do? Yeah, I need to get this decimal here and move it here. This needs to be 1.2. But I can't just willy-nilly move decimals without changing exponents. And this would be the note I lived myself. I moved this one place, and I made it one smaller. So you need to make this one bigger. You have to think opposites when it comes to this. So it ends up being 1.2 times 10 to the 8th power. Madisonian.
I'm confused on number 5.
Well, no more confused than I would be. And number 5, first of all, who drew this on a coordinate system? Yeah, don't. It doesn't say to draw it. All it says is it is dilated, which means made bigger by a scale factor of 3. Factor means multiplication. You are just taking everything times 3. Watch. times 3 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 times 3. So you're going to get 6 comma 6. So negative 3 comma 6, negative 3, negative 3, and 6 comma negative 3. Didn't say to necessarily draw it. Didn't say to compare their areas. If it would have said to compare their areas, if they would have said to give perimeters, blah, 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 you'd have to draw it. They just said, it's a skill factor of 3. I can't imagine somebody getting this wrong on tomorrow's test. Not just because it's that. Console.
How do you do number 6?
Number 6. Oh, the measure of angle x. Well, to do number 6, I guess I need to know a couple things. Okay, I need to know first of all that in a triangle, there are how many degrees? What's that? Joseph says 180 degrees, and I agree. I need to know that this little corner thing always stands for how many degrees? 90 degrees. I need to know, first of all, this is not 2 parallel lines cut by a transversal. No parallel lines here. Okay, so you can't use any of that stuff there, but you can use this. I need to figure out the measurement of this angle, because if I know this angle, I can add it to 90 degrees and then take that and subtract it from 180. How do I know how big that angle is? Let's use a little mathematical jargon. Those two angles add up to a straight line, and everybody knows in a straight line, Chase, there are, a straight line, a line is 180 degrees. So you say 130 plus what gives me 180 degrees, Sarah Grace? 130 plus what gives me 180? Makes a straight line, huh? 40 is 170. 130 plus 40 is 170. 50. By the way, what is the mathematical term for two angles that added together give you a straight line? Somebody. That one was, oh boy, I got all the time in the world. How about this? Two angles added together that give you 90 degrees are called complementary. Two angles added together that give you a straight line are called supplementary. They're supplementary angles. So once I know that this is 50 degrees, there's a couple ways to think about this. These have to add up to 180 degrees. So 50 plus 90 is 140. If you have 140 degrees, how many more do you need to make 180? 40. Or, since you know this is 90 degrees, you know these two have to add up to 90 degrees. So 50 plus 40 is 90 for those angles there. What if they asked you this angle? What if they said angle Y is how many degrees? What would it be? Not 130. 140 because X and Y have to be supplementary, so it has to form a straight line, so that would have to be 140 degrees to make 180. This has sure been fun so far. Emma Miller?
How do you do number 8?
Who?
8.
I love number 8. Oh, interesting. Very interesting. It don't really matter what that a human hair is this. They just said change this into standard form. What did you get for an answer? Oh, she didn't get an answer? How do you change scientific to standard?
You add 0.
There is where people go wrong, and I told you that, children. Please understand, you don't, thinking about it like you have to add zeros gets you the wrong answer because you think you have to add 5 zeros because that's the exponent. That is not the case. You need to think about it like this. I have to move the decimal 5 places. And if I have to add zeros in order to do that, that's fine. But if I start with this and I move it 5 places, by the way, if it's negative, it means it's a decimal number and you have to move the decimal left. So I have to go 1, 2, 3, 4, 5. My decimal is here, and that's where I do need to add zeros. But if you think about it like adding zeros, people always think they add 5 zeros here and put the decimal, but that's not true because one of the places gets taken up with that number between 1 and 10. So the answer is just 4 zeros and an 8. How many people put 5 zeros? How many people won't do it tomorrow? That's the key. So, by the way, that's pretty thin, although that's meters. That's not centimeters or millimeters, so you can take a couple of whatever, thousands off it. More questions, Sophia?
How would you number 15?
Have we not done 15? I love 15. Oh, yeah. Here's the question always I ask on this. How many terms are there? Layton Purdue, how many terms? Layton is shrugging her shoulders. How many terms do we see there? Emma?
0.
Oh, there's 1. There's 1. Terms are separated by addition and subtraction signs. There are no addition and subtraction signs, so this is not terms. This is all multiplication. All it is. And you're just simplifying. There's no equal signs. You're not telling me x equals anything. You're just simplifying this. 2 to the 3rd power is 2 times 2 times 2. What is 2 times 2 times 2? 8. 8. When you multiply like bases together, what's the rule with the exponents? You do what to them? X to the negative 1 times x to the 3rd is what and y? What do you do to their exponents? I can't hear anything. You add exponents when you multiply. For the same reason x times, why is x times x squared? Because it's x to the 1st times x to the 1st. You add those together, you get 2. Here you're adding a negative 1 and a positive 3. If you put a negative 1 with a positive 3, Sarah Grace, you end up with? Say it loud and proud. 2. X to the negative 1 times x to the 3rd is x squared. Then you have that y to the 0 power. Anything to the 0 power is 1. So I could put a 1 here, but it just clogs up everything and it doesn't matter because 1 times this is itself. So if it's a 1 with all those other things, it's just all those other things. We don't put 1 times a bunch of stuff. It's just 8x squared. The y really goes away because the 0 power is 1. Console. 10? Is that on this page or the other? Oh, there it is. Bag containing 10 ready, 20 white, and 30 blue marbles. If 1 marble is drawn in the bag, what's the probability the marble is not red? Probability of not red. That's what I'm looking for. Generally speaking, I tell you to draw all those marbles. That might take a while. I don't know if we should do it or not, but you know, let's just say we have 10 reds, 30 blues, and
20 whites.
20 whites. How do I get the probability of not red? How do I get probability of anything? Well, I put the total number of everything on the bottom. If you have all this, what is the total number of marbles you have? 30, 40, 50, 60. On top is what you want. How many of the marbles are not red? Well, if they're not red, then they have to be blue or white. How many is that? Huh?
50.
Yeah, 30 plus 20 is 50. So there's my probability. It just needs to be reduced. Divide by 10, divide by 10. Your probability is 5/6 that you will pull a not red marble. Zachary.
How would you encode
33. Machine can produce 20 plastic dinosaurs in 8 minutes. How many can it produce in an hour? So here's the deal, Zachary. You need to make this a ratio, and I guess you could use a ratio box. Okay, and in it you can put example number 1. What am I comparing? I'm comparing plastic dinosaurs to how many minutes? How many plastic dinosaurs can I do in 8 minutes? 120 plastic dinosaurs in 8 minutes. Here I'm looking for case number 2 or example number 2. I don't want this to be in minutes. I don't want 8 minutes, but I want to be an hour. But we want to be in the same unit of measurement, so an hour is how many minutes? So you want to know how many you can make in 60 minutes. And this goes back to that one I just did before. If you can think of no other way to do this, then by all means cross multiply and get 8 times n equals 120 times 60, which means 8n equals 7,200. Divide by 8, divide by 8, and you can do the math, but it's 900. Or, I don't know, Margot. Could I reduce 120 over 8 or not? What's it come out to be? I believe 8 goes into 8 once, and 8 goes into 120 15 times. So 1 times what is 60? 60. 15 times 60 is, guess what? 900. That is plastic dinosaurs. So much in math is related. Any of you related? John, you related in your class? So?
How would you number 17?
Number 7. Is that the prism one? No.
No.
Oh yeah. So, do you see an equal sign?
No.
Alright, so I'm not getting x equals anything. I'm just simplifying and combining like terms. The rule for combining like terms is have to be the same letters to the same exponents. So the only way I put an x squared together is if I have another x squared. Do I have another x squared? So if I have 5x squared and I add another x squared, I just have 6x squared. The exponents don't change. That's only when you multiply. X squared times x squared is x to the 4th. X squared plus x squared is 2x squared. Now, here's where people go astray. Minus 3x and a minus x. Again, you are not multiplying. It's not a negative times a negative. It's not going to be positive. Minus 3x means you have 3 minus x's. Here you have another minus x. How many minus x's do I have? I have 4 minus x's. It doesn't become positive because it's not multiplication. If these were times each other, yes, we get positive 3x squared. But they're not. It's adding and subtracting. virtually everything else. It's got to Emma Miller.
How do you do number 1?
Number 1. Well, the contractor rents a storage room for the rooms. Alright, this is the key word here. Ladies and gentlemen, when you talk about capacity, you are talking volume. And I'm drawing my little thing there. A storage room is 20 feet long, 10 feet wide, and 8 feet high. Here's my storage room. I am looking for volume. Volume of a rectangular prism, ladies and gentlemen, is length times width times height. You are just going to multiply the 3 dimensions together. 20 times 10 times 8. In whatever order you want, it don't make no difference. 20 times 10 is 200 times 8 is 1600, whatever that is. Huge. Again, note to self tomorrow is probably just multiply the 3 dimensions together. Split into the 3rd dimension. Where do we still have to go? Autumn?
How do you do number 12?
Number 12. Is that on this page or the other one? I think I found it. Now, Autumn, do you see an equal sign?
Yeah.
That means you will get x equals something. Compound equation, how do I figure that out? How do I get x by itself? First thing you always do is get rid of the adding and subtract. How do I get rid of a plus 1.8? Connor? I subtract 1.8. And when I subtract 1.8, I have to line up my decimals. Did I do something wrong? 5, 10, 2, I get 4.2, and that equals 3x. Now how do I solve for x? How do I get rid of the 3 times the x, Andrew? Look at these band people just jumping right in and we're getting answers. Now we divide by decimals. There's no decimal in 3, so I don't have to worry about moving anything. It just comes straight up. 1.4 is what x would equal. Let's see what we're at here. So, well, number 11, by the way, this is the 3rd problem we've had like this. 3rd problem like number 11. Either you can try to reduce and see if you can go across, or the easiest, well, not the easiest, but the way that always works is you multiply the diagonals. 20 times x equals 12 times 35. 20x equals, anybody 12 times 35, what's that, 70? 420? Is that right?
Yes.
Equals 420. Divide by 20, divide by 20, cut off the zeros. 21, I'm not going to do all that math because it's going to take too long. Or, children, if you can see this, you can reduce this fraction here. What goes into those? 4. Divide by 4, you get 3/5. And then you can go from 5 to 35 by multiplying by 7. And you still get your 21 over here. That's a 3rd ratio problem we've had, or equal fractions, or proportions, or whatever you want to call it. I'm ready for a deep breath. Not you. Any other ones? What do we still have left?
I don't think so. I mean, only 4 left.
Well, this one you should. That one should be a no-brainer, kind of it. We did everything there.
Yeah. So number 4. 419.
4. We let's just do number 4 just because. I'll feel better if we do it. Use unit multipliers to convert that into that. If you follow the rules of unit multiplier, you take your given thing, you put it over 1. 123 feet over 1. Here's your unit multiplier. What's my number one rule with using multipliers? I want labels to cross off, Madison, so what has to happen?
3 feet has to go on the bottom.
Because I need feet to cross off, if it's on top here, it has to go on bottom, the 3 goes with it, yards goes on top, that's what I want to make it. The feet cross cancel, and it's 123 times 1, which is 123, over 1 times 3, which is 3. You do the division, you end up with 41 yards. No rain, no way, no how. That has to be the end, because I got